Hey guys, so today I want to talk about how we can take the two things we've been talking about and add in a third element of algebra, which is what if we have variables, okay? So we got a lot of vocab. This is mainly vocab notes. This is lesson 6-3. We're going to talk about algebra, variables, and expressions. Variables and expressions. So we're going to make sure we are all on the same page and understand all the material now. Dun da da da! February! Yay! Okay, so what on earth do I mean by algebra? Algebra. Well, guess what? It's a language. That's why sometimes you have a hard time understanding it, because it's a foreign language. So it's a language of symbols, and that's numbers and operations. Including variables. Okay, well, that leads me to another word. What do I mean by variables? And variables, or let's just say variable. We'll do it singular. Fix that, variable. And that's going to be a symbol, usually a letter, used to represent an unknown value. Oops. So something we don't know. We hold the place with a letter called a variable so that we can explore possible answers. Okay. Its value changes with each problem it shows up in. So basically what I'm saying, shows up in, is if I have x in one problem, it may turn out to have a value of 7, but that same variable x could equal 3 in a different problem, and x in a third problem could equal -1. Okay, so that variable, when we defined it, it's for that problem only, and so every time that variable shows up in a new problem, it can be worth something else. Okay, so now what we're going to do is talk about algebraic expressions. So we talked about expressions the other day being a way of writing a math phrase, so it doesn't contain an equal sign, but it contains numbers and operations. But because I throw in the word algebraic, it means it's also going to include something that means algebra, some sort of unknown. So this is going to be a numerical expression. So we're talking about numbers and operations. Numbers and operations. With, and here comes the key word, variables. So let's give that a little box, make him stand out. With variables included. So once I start using variables, now it's called algebraic or algebra. So, a set of directions that you will see when we're working on this stuff is evaluate. And we've talked about this word before, and if you think about it, it almost spells out the word value. So it's basically saying, what is this problem worth? You know, what is its number? So we're going to replace the variable with its value. Oops, sorry. Now this value is going to be given to you in the problem. Then find the value of the expression. So if I know what the value of the variable is, I substitute it in, and then I can evaluate that expression now that I have numbers and operations only. Okay, I've got one more word, and I just used it, and that's the word substitution. Man, been doing this a lot with algebra lately, doing substitution. It's a big thing in geometry class, too. So substitution is the act of replacing a variable with its value. Okay, so somebody tells me the value, I substitute it in for the variable, and then I'm able to solve. Now, one thing I do want to talk about is that we can show multiplication different ways. So I'm going to say ways to show multiplication with variables. To show multiplication with variables. So we can do 5, and then we can use the multiplication symbol for x. So that's 5 times x. I can show it with parentheses, so 5 parentheses x. So when I have a number that butts up to parentheses, that's multiplication. So that also means 5 times x. And then I could just put 5 next to x. That means 5 times x. And I can actually use double, let's see, let me find a good color. I can also use double parentheses. Quantity 5 times the quantity x. That also means 5 times x. Okay? So on the next slide, we're going to write down how do we actually find the value of an algebraic expression. So I'm going to write down a couple of steps, and then we're going to practice a couple problems. So what do we do to find the value of an algebraic expression? All right, so first thing we're going to do is what we consider a prep step. That means before we do any calculations. So number 1, we're going to substitute the value given for each variable. So sometimes what that's saying is we may have more than one variable in an expression. That's okay. If we know all their values, we can go ahead and solve. Next, we're going to solve, excuse me, using the order of operations. So that was from our notes from yesterday. And we've got 4 major components. And the first one is going to be G for grouping symbols. And so that includes, if you remember from the notes from yesterday, parentheses, brackets, braces, fraction bar. And then we had exponents. So E for exponents. They take the second priority. And remember, if you have grouping symbols, then whatever math you have inside the grouping symbols, then you also follow the order of operations. Then we had the partners, M and D, which is multiplication or division, or multiply, divide. And remember, it's whatever shows up in the problem as you read it from left to right. And last but not least, we've got A and S, and again, as you go from left to right, you're going to add or subtract. So again, anytime you have an algebraic expression, we're going to use order of operations. So, directions are going to ask us to evaluate each expression. So evaluate means to find the answer, find the value. Now notice it doesn't say what kind of expression, so let's see what we end up with. Maybe we have just a numeric one, or maybe we have an algebraic one. So we have A plus 8, and then it says if A equals 6. Okay, so what we're going to do is we're going to take that value for A, which is 6, and we're going to substitute it back into the expression where we see A. So we have 6 plus 8. So on your homework, write out the original problem, show me the substitution, and then do the math. And we get 14. So that's my answer for this problem. Let's try a second one. We have 9C, and then if, they have to give us our definition, C equals, 1/3. So we're going to take that 1/3, and where we see C, we're going to put it in. Now notice that we have the 9 that butts up to the C, so what that means is 9 times the C value. So 9 times 1/3. So to make this problem a little bit easier, I can go ahead and make 9 a fraction by giving it a denominator of 1, and then I look for any kind of cross products, or cross canceling, excuse me. So on this diagonal, 3 goes into itself once, and into 9 3 times. So when I multiply straight across, I get 3 times 1 is 3, over 1 times 1, and then I simplify that down. 3 divided by 1 is 3, and there's my answer. Okay, next we have 5t plus 4, and then if t equals 3. I'm going to write that again. Everything's just kind of getting on top of each other here. So what I'm going to do is take that 3, and I'm going to substitute it in where I see t. Now notice what was going on. We had 5, and it butted up to the t, so that means 5 times the t value, which we know is 3. And then we're going to add 4. So this is the first time we're really going to use order of operations because we have more than one operation going on. So order of operations says grouping symbols, nah. Exponents, nah. multiplication or division, ding, 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 ding. So we're actually going to multiply the 5 times the 3 first. So that's going to give me 15, and then I'm going to add 4 to that, and that gives me a total of 19. So 2 operations, multiplication, followed by addition. Okay? All right. Only got 2 problems left. My kitty cat gets out of my view. It's going to make life easier. So this one we've got is 50 minus 3d if d equals 12. So I'm going to go ahead and take that 12, and I'm going to substitute it in where I see d. So that gives me 50 minus 3, and again, variable and number next to each other is going to be a multiplication, and we're going to substitute in 12 for the d. So again, more than one operation, so we follow order of operations. There's no parentheses, no exponents, but I do have multiplication. So we're going to do him first. 50 doesn't change, minus doesn't change, and 3 times 12 is 36. I subtract 50, take away 36, and I get the grand total of 14. Okay? And then last but not least, we've got 6s squared if s equals 1/2. So another fraction. So I'm going to take 1/2, and I'm going to substitute it where I see s. Oh my goodness, this problem just got complicated. Do you see what we have to contend with? We've got 6 times, and then we're going to take 1/2, and we're going to square that answer. Okay, so let's deal with a component of this off to the side. What does it mean to square 1/2? Remember what exponents mean? It means to multiply, and the exponent of 2 means you're going to have 2 halves. So I'm going to multiply straight across, and I get 1 times 1 over 2 times 2, and I get 1/4. So this problem now becomes 6 times 1/4. Now what's interesting is I can go ahead and give a denominator of 1 to my 6, and when I multiply, oh, sorry, I forgot to put the 1. I put the fraction bar, but not the 1. Oops, there we go. And so what we're going to do, sorry, my roommate came home. There's that weird pause because I'm trying to figure out, oh, I got to pause this. All right, so I'm going to see if I can do any canceling. So let's find a good canceling color. This guy. I noticed that 2 can go into 4 twice, and 2 can go into 6 3 times. So I multiply straight across. 3 times 1 is 3. 1 times 2 is 2. And there's your answer. Now, if you wanted to be fancy, you could change it, convert it into a mixed number. 2 goes into 3 once, with 1 left over. So you could write the answer as 1 1/2. Okay? All right. Have fun with this, guys.